Hello, welcome back to the Land Timber Stream. Hope you're having a good Tuesday. We're here. We only process the good bits. We discard all the sad bits. So, hope you're having a good day. We're going to talk some multicast and trying to round out the multicast. Don't want to rush it too much. I got to this one, Multicast BGP. I'll talk about it in a little bit. Your full resolution photos, videos will not fit on this Mac. Really? I keep getting some prompts about storage, but I've got plenty of storage. That's interesting. This prompt may come up in a minute. I will. Ooh, sorry about that. So, yeah, I had some great, well, I say fun and frustration in Azure today. Many may know at work. My day job does involve networking. It also involves some DevOps, Azure, Scrum, Agile, all that kind of stuff. So that has been really interesting, man. I've been learning about some really cool automation tools that Azure has that I didn't know about. And one day, I was talking a little while ago about automating a couple things that I want to do, very simple things, excuse me, with the lab. And I'm dropping some frames here. Sorry, folks. Let me try to figure out what that is. Bear with me a second. And that's not what I want. Hey, Casadix, how are you, man? How are you doing? You're probably getting a few drop frames. This is not what I wanted. I didn't want the Azure Storage Explorer. My PC is doing some interesting things here. It's funny, I used this computer today, had no problems. Only when I started the stream, no, let's not do this right now. Sorry about that. Everything was fine until I started streaming. Yeah, bear with me just one moment, folks. All right. Oh, that's good to know, Casadix. I'm glad you're doing well. We'll just carry right along and see how this goes. So yeah, I started this multicast BGP lab, and I actually got through it today. It was one of those labs where I could not find much information about the multicast BGP extensions. I really could not find much at all. And then, I looked through network lessons. I looked through the INE materials. I looked through, there was a Cisco document that had a section about the BGP extensions, but very little. So I was really struggling. And I was like, you know what? I don't get it. So I opened up the lab, the INE workbook, and I looked at the answer key. And it was funny, I started, okay, well, I don't know what I'm doing here, but I'm just going to go ahead and type out this configuration. And I'm going to see what it looks like in Wireshark. And sure enough, after I built the lab, and I've got it built now, and I'll show it to you, but after I built it, one command in particular was like an aha moment, like, oh, boom, I got it. That's what this is for. I guess what I was expecting to see is when you do like multicast routing, you see these S, G's or star, G entries. I thought that, BGP, like a lot of other address families, that it was going to somehow advertise this routes and use different attributes or use, communities or something to communicate this information. And that is not what it is doing. What Multicast BGP is doing is it is providing you sort of a different unicast routing table to use for RPF checks. And where this bore out to me was if you do, for example, show BGP. It's funny, you know, for the longest time, I've been doing this format. A lot of people do show IPBGP, by the way, which that implies a couple of things. When you do show IPBGP, it implies that you are looking for IPv4 information and that you're looking for unicast information by default. Someone a long time ago in Router Gods was like, you know, if I just got used to doing show BGP, then doing the address family and the SAFI. And that's an easier thing to remember, because if you want to see, for example, show BGP IPv4, you don't have to change anything in the beginning, right, of your show command. You can do show IPv4, show VPNv4, or show IPv6, and then you could go to the modifier, and here you can do. So I've been doing. Everybody's like, why are you not everybody, but people have commented, why don't you just do show IPBGP? Why are you doing show BGP IPv4 uni? Yes, it is a few extra commands, but at the same time, it has prepared me for this moment, which is I'm going to do show BGP IPv4 multi. And that's all I have to remember. But anyway, what brought this out, what really clinched it for me, and I've got the lab loaded up right now in Azure, and I am doing the lab is configured, so we don't have to do any configuration right now. I just want to go back through the workbook and look at the verification. But when you do, this is how you see it, for example, show BGP IPv4 unicast, and let's just find a prefix. We see, for example, this is router 3, and the topology is this. This is a new topology, by the way, which we're going to use in the next lab also, which is MSDP. And this is INE, of course. It's publicly available in a link below. But we're on router 3 right now, which is in AS100, but it is also connected eBGP to AS200, to router 5 over this tunnel 35. So if we look here, we should see routes, of course, here, and we should see some routes over here that we have learned via BGP unicast. Also OSPF. So we should know these routes actually via OSPF also, right? I think. But for example, take, we basically have two sort of paths here out of 100. We can go over router 3's link. We also have router 6's link. And what BGP multicast extension is going to allow you to do is say, all right, I've got incongruent topologies here for unicast and multicast. Like I want multicast to go one way, whereas unicast is fine to go another way. Typically, you would do a static M route for that, right? Well, that can get out of hand for, you know, a lot of prefixes. Maybe you don't want all routes, all multicast routes to go this way. Maybe you just want some of them. And that's where you can use policies with BGP. And we're not going to advertise multicast routes per se. We're just going to change the preference of RPF checks on unicast routes. Which remember, Protocol Independent Multicast, PIM, is relying on the RPF check and the underlying unicast. But this is a way for us to tell RPF, hey, look, I know this is how you normally check for doing RPF check for loop avoidance, or loop prevention, I should say. Instead of that, we have a more preferred entry that we want you to look at for your RPF check. And that will also be used, of course, for other decisions, right? Designated forwarder, etc. So that's really what it is. And once I figured that out, I was like, oh, makes so much sense. So let's take, for example, show BGP IPv4 unicast family. Let's look at 150.1.10.10. All right, notice here we have a single entry. It is learned from AS200. And this is actually the neighbor that we're learning it from, 155.1.105. Again, we know this is router 10, right? Local pref 100. But what if we look at the same show BGP IPv4 multi, 150.1.10.10? Okay, this is not a good example. I think the best example was the requirements of this lab were to create a multicast border here. Yeah, maybe this is on router 6. Show BGP IPv4 uni. Okay, yeah, so for some of these, we've got two routes to take. So for example, for router 6, we have two next hops that we have learned about, but we're going to prefer the route over router 4, which makes sense. So if we're on router 6 and we want to go to router 5, I think OSPF is running over the tunnel interface. Whoa. I did not tell you to do that, PC. That is all you. I don't know where you got that from. So anyway, right now it prefers to go, I've got two routes. My preferred route is this way. That's great. But if we created a border here, a multicast border, which I believe we have, we don't want to use the unicast preferred path for our RPF check and to make any, decisions that we're going to let any other multicast router know, like router 3 or router 4, right? So what we do is we do the same command. So let's see, what did I say, 150.1.5.5, right? Yeah, we got two routes. The best is number 1. Oh, so it's actually going to go over, let's see why that is. 150.133, and I believe this is because it is a internal. No, that would not be it. Origin incomplete. Cluster list. I might have to look at the details to see why this is preferred, but it is. Highlight, go away. So let's look at multicast, however. Show BGP IPv4 multi. Okay, yeah, it's saying go over 3 as well, but notice it does not even have the link over router 4. So this is not the best example, but as we can see here, we have applied some sort of policy to the multicast address family. And it is saying you don't even have this option. And let's look at, I believe the reason why is we have a boundary running here, or on router 4. I think 4 is actually the best example. Yeah, we have a BSR border boundary. So let's look at show BGP IPv4 uni. I think here's our best example. Okay, yeah, look at this. So router 7. So for router 4 to get to router 7 in the unicast routing table, My best path is number 1, which is external. That makes sense. And it says go this way to get to router 7. Makes good sense, right? I have another path that I've learned over BGP to go this way, but this is better. It's eBGP neighbor versus an iBGP neighbor. If I do it via multicast, notice this. It says nope. This is a better way to go. So that's what the multicast extension is for BGP, which I didn't really get until I ran these commands. I was like, and it wasn't even in the workbook. The workbook has me doing some other verification. And I'm going to check now. Let's take a look. Of course, this command I already knew, show BGP IPv4 multi summary. So this is where we have BGP adjacencies or connections. And we have them using the multicast address family, not the unicast. And we're actually doing, let's see, BGP router identification, localized number. One AS path entry. Yeah, we have some policies here. Oh no, that's not what that means. So as we could see, we have unicast and we have multicast. And what's interesting is we're redistributing. Oh, we do have a prepend here. So yeah, we're redistributing OSPF into both IPv4 and IPv4 unicast and IPv4 multicast. We're redistributing OSPF, but here we have a route map. Look, we're prepending the path, so we don't want to prefer multicast RPF checks to look at these prefixes first. So in the workbook, now usually the workbook is like chock full of like commands you wouldn't even ever really use, but they're just kind of teaching you. This one has like 3 screenshots. That's it for verification. I find that unusual. Yeah, and the BSR border command is to prevent BSR information from being advertised this way. So, yeah, I just want to take a look at this. Let's see, what else did I want to look at? On router 5, show. So right now there is a tunnel on router 8. I think that's just leftover garbage. Could have swore I took this out. Yeah. So now it should. Yeah. So 5 is a tunnel, but over here in AS, in this AS, let's look at router 7. He's the tunnel, right? Let's look at router 3, which is a boundary router in BGP anyway. 7, yeah. So if I do show IP PIM interface, notice that I am paired with my own tunnel interface. But router 3 is not a neighbor paired. Is not a neighbor, a PIM neighbor with router 5. So actually, multicast traffic should not go this way. It should stay inside of this AS. Okay, I think what this is going to lead to is the next protocol, which is MSDP, because multicast source discovery protocol. Because right now, is 6? Yeah, I guess there is no. I guess these are isolated islands, pretty much, for multicast. There's no way they could come over because. Well, let's see. Let's look at router 6. Yeah, I'm probably getting ahead of myself here. No, router 4 is enabled. Sparse mode. But yeah, traffic would probably just get Mac has been doing a couple of kind of little strange things lately. Hashtag mouse stress. All right, so yeah, but I don't. The thing is, and this is going to, I think, lead well into the next lab. These are sort of isolated environments, except there is a bridge here. So these are PIM neighbors, but router 6 is not really going to learn. We're using Bootstrap router. And router 6's Bootstrap router is 7. So this is the only mapping agent he's going to know about. If a source registers with this mapping agent, for example, let's say 10 started sending a multicast stream, it would get to router 5 and it would get to router 4 potentially. But if the traffic got forwarded to router 6, let me think about this. So router 6 would say, well, we'd have to have a shared tree, right? Yeah, we would, because this is sparse. So router 6 could let router 4 know, but if there was an IGMP host over here, router 6 would never send it this way. So 4 would never learn, because 6 is only going to forward it to the rendezvous point. So they can't have a shared tree because they're using 2 different rendezvous points. But that is the purpose of MSDP, and I think that's what we're going to go to next. Maybe that's why they didn't say much about this in this particular lab. I'm actually going to mark this lab complete. I am good with that. So let's move on to MSDP. And it's the same topology. So we've got this new topology up. And where did it go? Oh my goodness. This computer has a mind of its own today. Okay. So we've got this new topology, right, which we've loaded up. I think I need to inter-domain multicast MSDP is the initial config. All right, what we're going to do is that's what I'm using. So I'm just going to stop all the routers and restart them. So we'll stop all nodes, wipe all nodes, start all nodes. Console all nodes. It's that quick. All right, this lab, man, I've not really studied this that well. I studied for this material for the written MSDP, but obviously I've never labbed it. So we're going to look at the requirements here in a minute. This is where we get into the SA messages, source advertisements. 2, 3, 4, 5, 6, 7, 8, 9, 10. What was that prompt? Okay, just missing router 1. All right, so requirements are R5 and R8 as RPs for AS200 using BSR, okay. R10 is the BSR, interesting. Ensure there's a BSR border between ASs, okay. AS100 is pre-configured with a static RP, R7. Okay, so we're using static on the other side. Create an MSDP peering session. R7 and R8, R5 and R7. Sourcing from the loopbacks. Okay, I can handle all this, I think, without a problem. Beyond that, we'll see. And hopefully I got this topology right. So let's go over here, mosey on over here to AS200. And we want, first we should put in our BSR borders, I would think. Show run section PIM. Okay, yeah, it's not on there. Interface Jazz 0, 1, 146, IP PIM, BSR border. And we also, so we want a border. I closed it already. We're just gonna go full screen on this bad boy. So we can do that. So we want a border here. I think we want a border here. I don't know if these are PIM neighbors. Let's see. Router 4 and router 8. Okay, that's fine. Let's look on this side too, router 6 and router 3. Router 7, okay, that's good. Okay, that's good. Oh, let me check the interfaces because it seems like we should have more neighbors than that. Okay, that's up. Up. Well, the fact that we have any neighbors means the interfaces must be up. Okay. Okay, good. All right, what did it say? Which border? Ensure BSR border router between ASs. Well, I put a command in here. I don't think I need it, though. Let's check our configs and make sure. Why would I put the border command if it's not running PIM on an interface? Or they just ask me to put it in just for busy work. For lack of a better term, other terms I want to use, but interdomain multicast, MSDP. Oh, maybe I don't have the right topology loaded. Hey man, please slide a little console to the right so we can see it. Oh, okay. Yeah, absolutely. Thank you. Appreciate that call out, man. I switched screens and I didn't actually should do this. There we go. Appreciate that, Casadix, as always. Okay, so this screen should go here. So we can do this. And, but I am afraid that, all right, I double clicked on a text file. Expect that text file to open, and it has. You know what? I need to go through and, yeah, this is a different topology than what I loaded. Shoot. Okay, that's fine. All right, let's go into, I had a launcher window open. I'm having major, like, I don't know what it is about today. I'm having major window issues. So I have here a folder that has a copy of all the initial configs. See, I was using this one. I actually need to be using this one. So we're going to check each one. Router 2. Not much going on there. I think we're okay, but just in case, I'm going to paste this in here. If paste works, allow. Thank you. Okay, then we'll go to router. You know what? I need to take my time and do this correctly. I don't know that this is. I could be introducing a mistake, so let's do this right. Stop all nodes. Wipe all nodes. Close lab. And we're going to make a copy of this. We're going to clone it and call it MSDP. And we're going to edit this lab. Well, open. And let's edit this right proper. So there's no doubt later on. I had this window open. I could have sworn I had. That's just me closing the windows too fast. Story of my life. All right, so we're gonna go here. That's Technology Labs. Interdomain multicast MSDP. And I'm gonna go to each one. Man, we just can't share windows, can we? Let's move that. My goodness, I'm getting dizzy. All right. That's router 1. And save, and then we'll do router 2. One thing that is happening here, I noticed, well, not on that one. This command fails, IP multicast routing distributed. I don't know how that seeped in here, but that doesn't work on this platform. So I have to remember to come here and edit this. That command will work. Somebody missed that, I guess. Okay, router 4. Save. 5. Router 6. And 3 more to go here. I like that they're doing the peer BGP peer group. Okay, router 8. Nine. And 10. Notice it says enable conf t. That's interesting. Okay. Now we can start all nodes. And console to all nodes. Cool. Now we should be on the right topology for sure. Without a doubt. Okay, so router 5 and router 8 is RP. Yeah, I just was not understanding these instructions, and I'm thinking maybe that's because my topology is not right. Okay, we don't need switch 1, switch 2, switch 3, or the Linux box, so we can stop those. Stop, stop, and stop. So yeah, BSR. See if these interfaces come up this time. Hopefully they do. Never actually sat there and read the disclaimer. All right, see if we can get this set so everybody can see what's going on. All right, router 1 is up. We actually need to look at, first I want to look at router 6 or 4. And we can see if we even need a BSR border command. Ah, we do. Okay. That's more like it. 01146 IPPIM BSR border. And now let's look at router 6 as well. Aha, yes. Raise 01146. That will filter incoming as well, right? So we don't want to get BSR border advertisements inbound. We've cut it off from router 6, but just in case. So let's look at router 3. Okay, the tunnel interface. So we need to put it here as well, don't we? Interface IPPIM BSR border. And we need it on router 5 then. T35. Yep, that's the only place. PIM BSR border. Now let's configure our BSR borders over on NAS 100. And you have to be behind here, don't you? So router 5 and router 8 will be RPs using BSR. And B10 is a BSR. Interesting topology, all right? So we're going to say IPPIM BSR candidate loopback 0. Let's put a hash on here. We don't have to, but... And then show IPPIM interface. Okay, it's running on loopback 0, so that's fine. Now our candidate RPs are going to be 5 and 8. It's so easy, BSR, compared to auto RP. I love it. PPIM RP candidate L0 and router 8. So we should get 2 tunnels, which we do. Like on router 4 should have 2 tunnels. And he does. And router 6 should not have any. Well, it's a static RP. So he has it with router 7. Good. AS100 is pre-configured with static RP. Okay, easy enough. Now, create MSDP peering sessions sourcing from the loopbacks. For this, I'm going to have to rely upon... let's go to the Cisco doc. And we'll go to the configuration guide for multicast. Actually, PIM. Yeah, I usually use Safari. That's why these are not highlighted. I have been here before. Oh, 15.3. That's why it looks weird. I'll just go to 15.6. Config guides. There we go. IPPIM. And there should be, okay, here we go. I've not actually read this. Let's go straight to the configuration examples. Okay, yeah, IP MSDP. Oh, let's that's really all there is to it, isn't there? Let's turn on some, let's do some PCAPs here on router. Oh, you know what I want to do on router 5? It's probably using encryption. Let's turn that off. Yeah. Remove tunnel protection. No tunnel protection. DMVPN underscore profile. Tunnel will go down. And it should come back up. Boom. All right. That will converge, and then all we have to do, it looks like, are we capturing? Yeah, let's go ahead and start capturing. And we should be able to see, for the first time, I'll see some live MSDP traffic. So this is our command format, IP MSDP peer. I see this is between like 3. So we have to do between router 7 and router 8. Yeah, so essentially router 7 and router 8 and router 5 and router 7. Okay. So IP MSDP, is that right? Peer. And the loopback address, what we're using, 150.1.8.8. Source L0. Connect source. .10.10. Was that right? This is router 7. No, it's router 5, yeah. Because 5 is the RP. 10 is the bootstrap router. Okay, let's go here to router 5. Okay, that's up. So IP MSDP peer 150.1.7.7 source. Connect source using L0. Hey, we got a peer up. Cool. And over router 8. And we should get it there. So there's 3 RPs on the map here. All 3 of them should be able to exchange source information. And for that, we need to create some sources. So first of all, let's do our show IP MSDP peer. Nice. Oh, it has the AS here. So if we had not learned it, we could specify it. Session to peer going up. Well, I would hope so. I just typed a command. There's no filtering, no request, TTL threshold. Number of connection transitions to establish state, message counters. So a lot of information here. State up, reset 0, uptime, 7 seconds, message sent, received. Okay. Cool. What does that look like over here? Yeah, is there an MSDP filter? There is. So this is pretty simple, just keep alives. Because we don't have any groups yet. Yeah, TCP. All right, and they're sent like every few seconds, I guess. So let's create some traffic here. I'm just looking through the workbook and seeing what they use for okay, they join. Interesting. So this is going to have on router 4. We're going to use loopbacks, IPPIM sparse mode, IPIGMP join group. All right, and then router 9 all the way at the other end of the network. Join group 239.1.1.1. All right. Oh, no. No IP join group. That doesn't give us the same sort of hash algorithm. So we're going to do IP IGMP join group 239.1.1.2. Okay, there we go. So let's look at router 4. Oh, I did it over there as well. Interface L0, no, IP IGMP join group 239.222. Hey man, this kind of setup is used in which case? Like Netflix streams. So these are multiple domains. It's a good question. Like, let's look at our diagram. So these are different AS. It could be that you have different autonomous systems because they're under different control, right? So maybe you have department, maybe you have a legal department. This could be in a data center too, right? You have multiple. Okay, so this is maybe you have multi-tenancy in a data center. Your department, your team is responsible for provisioning resources in the data center. You have different hosts, different virtual machines, and you have them partitioned off in certain ways, right? Maybe unicast, they don't exchange all their information. So you're using BGP here, or maybe you're merging companies, right? This is Autonomous System 200, this is Autonomous System 100. But the first thing you connect is voice systems and music on hold. So you don't want to actually build separate music on hold servers. You want to bridge these domains for multicast Not necessarily all the unicast traffic yet. Maybe there's still, you want to apply different policies here, but you do want multicast traffic to cross. And in those cases, maybe you already had multicast traffic here, you already had multicast traffic here, but you want these to sort of join up, and you want your rendezvous points here to learn about your rendezvous points here, so that when router 9, for example, is now sending music on hold, or a video feed, right? Maybe the company is doing a merger video. We're all merging companies now. We're going to transmit this video on the LAN. We're going to broadcast it. So we want this multicast network, this domain here, to learn about sources over here. So router 9 is going to do this broadcast. And this is the RP, router 7 here, and this is router 8 is RP over here, and you got 1,000, PCs on each side. Well, now these rendezvous points are going to exchange source information. So we don't have a shared tree, maybe. My host over here cannot, due to RPF check failures, and we don't have fully routing, capabilities yet between, but this host can only, form a shared tree with router 7. Sorry, this host over here can only form a shared tree with router 8. If router 9 registers with router 7, router 8 will never know about it. So that's how they exchange their information. And you notice here that MSDP is exchanged unicast. So that's a potential example, I think. At least some that I've read about. So we've got these different. Now we should have star comma G trees in each multicast domain. And we do. We've got 239.111. So router 7 is like, I have receivers here. Now that we have MSDP, router 7 should be able to let, oh, you're very welcome. Should be able to let the RP over here, router 5 is an RP, right? No, yeah, he is. Yeah, so show IP mroute. So we enable, let's see, we enable these IGMP groups. Okay, yeah, so now we're going to transmit. Let's see, where are we going to send it from? Okay, router 10, yeah. So router 10, by the way, does this change our tunnels? Right. All right, so notice if I start sending over here, if I start sending multicast traffic from router 10, it's going to get to router 5, and router 5 is going to know, okay, I have to forward this out an oil of router 4 because I've got a receiver, router 4. But that traffic, unless router 5, this rendezvous point, he also needs to know that basically, hey, we've got listeners over here too. So router 10, if you're going to be sending this traffic, not only do I need to forward it this way, but we've got listeners over here as well in this domain. So let's look at router 5, for example, show IP mroute. Because we have router 9 as well. I'm not sure how that's going to get over there. Let's see. Oh, wrong address. It is going to router 9. So it's in this interface, out this interface, in this interface, out this interface. I'm not sure how it knows that. Oh, maybe router 4? Loopback 0. Let's go back to router 9. Yeah, it's interesting. I'm not sure how he's learning this information. It says multi-protocol BGP as well. That's interesting. So there's a lot to unpack here. So somehow router 7, through these MSDP messages, let's look at our MSDP messages. Therein, I'm sure, lies the clue. Okay, I had Wireshark up. Where did you go? Come back. Okay, source active. Here you go. S comma G block. Look at that. That's cool. All right. IPv4 is source active. So we're going to mark this packet. We're going to mark. Actually, we're going to unmark that. I'm not real sure about the mechanics of it. I know this is working. So I think what happens is any new source that router 5 or 8 learn about, they know that they're responsible for sending source active messages over to any MSDP peer, which is router 7. So router 7 then adds a multicast route. And then that's how router 9 knows to get to well, we have 7 already has a receiver because we have a shared tree, right? So I think we added it. Where did we add it? Here, yeah. So 7 already knows that he has a receiver. So when router 5 lets him know, hey, I've got a source. Then we build the S comma G, and the source is router 10. Problem is, though, I don't know how is the multicast message bridged. How is it actually sent? Because router 5, it's not in his oil, I don't think. Or is it? Let's look back there again. The RP can do that because it's a root of the shared tree within its domain. True, but once you know the traffic starts flowing, It's going to go on each PIM enabled interface, right? Okay, it is enabled on the tunnel interface, but if I look show IP PIM 239.112, oh, show IP M route. It only has one outgoing interface list. So it's only going to forward the traffic out that way. Let's send some more. I know it's reaching there, obviously. Oh, we've got multiple entries here. Look at this. We are forwarding it. Check it out. Okay. So that is because show IP MSDP. Where can we see the SAs? Aha, here we go. So this is how router 5 knows. So somehow he sent a source active over to router 7. But router 7, I guess, somehow let him know that, hey, I've got a receiver this way, so you need to add this to your oil. We almost need a receiver active, don't we? So we've got source active. But how do we get the... How does the interface get added to the oil? Okay, I'll bet here's probably what happens. We have a shared tree here, don't we? Yeah, so router 5 is like... Router 5, I guess, is not really concerned about where any receivers are here. Router 5 only needs to know about where the MSDP peer is and how to get to him. So he'll probably do an RPF check against the peer MSDP and adds that interface to the oil. That must be how it is. Yeah, because if we look at the route, let's actually look at the route. Show IP M route. Well, we've got it up here. Incoming is here, outgoing is tunnel 35, yeah. I'm a little puzzled by these multiple entries, though. I don't know why we have... It seems to be duplicated. They have the same flags and everything. This, of course, is because we're using ICMP. Router 8 is also going to originate, right, a packet all along the path. But I can't really distinguish these two multicast routes. Show IP mfib. FNS forward. So many flags. Negate signaling. Okay. IP mrib route. Well, I'm going to have to read up more on this, but I think at least that would make sense to me. I do want to tag a couple of these packets here, though, for my collection to add to my specimens. That sounded a little eerily like, what's his name from The Simpsons? Like the owner of the nuclear plant. I forget what his name is. All right, we're going to export these marked packets and add them to our collection. These are going to be MSDP peering. Cool. So I'm gonna research, that a little bit. I'm gonna read through it so detailed. This is a little bit of a better lesson than the last one. And then tomorrow we'll move on to Anycast RP. Now, definitely got to get to bed on time tonight because last night I got up late. Well, I went to bed on time, but got up like in the middle of the night. Had trouble sleeping. Did not make it to the gym, so can't let that happen tomorrow. Thanks for hanging out tonight. Appreciate it. Casadix, by the way, I want to make you a mod, my friend. You're such a faithful viewer, and you know the drill here. And so now you can create as many links or whatever, ban people, whatever you got to do. I trust you, man. Thanks so much for hanging out. Mods for everyone. CK Darby. How's it going, CK Darby? Great to see you tonight. We shall see you folks tomorrow. We'll do it again. We'll hit some. Let's take a quick inventory of the workbook here where we're at. I should be able to mark this one off. Man, we're getting close. Okay, so we got, you're welcome, Crusaders. We got Anycast RP. I'm looking forward to this. I love Anycast. I think Anycast is cool. It's cool. Anycast and the broadcast. And then we're going to do some snooping. I don't know if I'll need an actual catalyst switch for this. Hopefully not. We should be able to do this with our Advanced Technology Labs multicast diagrams. Same diagram. Oh, we got a new follower. Thank you so much for that follow, CK Darby. Appreciate it. Welcome to the Land Tamer stream as we are just closing down. Yeah, thanks so much for stopping by. Enjoy the networking and the good bits. We discard all evil bits here, all malformed bits. We only deal with good bits here on the Land Tamer channel. Folks, you can follow me. As you may know, I stream 7 p.m. Eastern time, Monday through Thursday. I'm off Friday evenings, and it varies on the weekends. You can follow me here on Twitch, Twitter, Instagram, at the Land Tamer, and on YouTube, where I upload all of the sessions. And we'll keep jamming on multicast, and it's looking pretty good. So we got tomorrow, Thursday night. It's looking good to start IPv6 on the weekend. And just to get a glimmer of the IPv6 goodness coming up, I love IPv6. I've become a big fan. I'm running IPv6 at home. Not all my traffic. I'm running dual stack. It's okay. Not all my traffic is IPv6, but it's interesting to see which sites. A lot of sites do support it now. Yeah, we should be able to get this done in February for sure. We're going to start with some real basic addressing things. UE64, IPv6 auto config, not too bad. Some routing, multi-protocol BGP, and PIM, of course. We're not going to leave out PIM. PIM is our friend now. I feel I feel like I could configure a basic lab pretty quickly with PIM IPv4. Oh, they've got tunneling on here. I did not know that was part of the lab blueprint. An isotap. Fun. And then QoS we're going to spend like a year on. No, not really, but it's going to be fun. All right, folks, that's going to wrap it up for tonight. Thanks so much for stopping by. We shall see you tomorrow, same time, 7 p.m., here on the Land Tamer stream. Have a great night, folks.